Welcome back, everybody. Our last week of class, first week back from break. Let's start today, kind of regrouping here on our Canvas. Recording, sharing, that's all good. Okay, so we've got class today, class on Thursday, our last two lectures. We got 4 soil orders left to cover between those 2 lectures. And then we have wrapped up all 12 soil orders in our whole semester in pedology class pretty much. I want to shout out what assignments we've got. Still past assignments. So the 2 taxonomy activities, taxonomy lab, taxonomy intro lab number 4, that one's graded, put in Canvas already. Taxonomy lab week 2, lab 5 is next. All these other ones, the field trip summary activity and the soil taxonomy challenge, you're welcome to turn those in still if you haven't already. Thank you to everyone who's gotten those in. Taxonomy challenge, we'll have more time to work on and discuss this Thursday in lab. So Thursday in lab will be our last time meeting and all hanging out together. We'll do our last little review activity for the whole semester on planning Kahoot. Everybody's familiar with Kahoot? Fun little trivia answer, buzz in independently. I'll have a little bit more structure to it. I'll share more about that on Thursday. That'll be the activity for the first 45 minutes, maybe an hour. And then the whole rest of the time I'll be around. Is up to you guys. You can finish up the taxonomy challenge, or you can finish up your poster projects. So you went out, you dug your soil pit. Hopefully you got a taxonomic classification or estimated classification for your project soil pit. And then you can put it together in a little poster presentation. Just another reminder about these. We've got final project resources here towards the bottom on Canvas. The rubric for it, instructions for it, and some example posters to look at here of what goes into a good quality, highly graded poster here. You do not have to print these out. These are just submit a PDF, upload it to Canvas. I'll make sure there's a place to do that, but you got photos of the profile. You can annotate it with like the annotate with the horizon labels here, horizonation, and then maybe drawing on it too if you want, or have other things to point out. Scenery around it, what the site looks like, maybe close-ups of any interesting features. This one had a big round, looked like a rock, but it was made of soil. A little bit of your description sheet there, and then look at this. Some background information, results and discussion of how you think it formed, appropriate land use, how it might differ from what the mapped soil series is for that location. Give it your classification right there. And just an overall summary of what you went out and what you found. So these are here examples. There's another one for your reference. And then also on Canvas, we've got in the discussions an opportunity for extra credit, our soil in the popular media. We've still got 2 examples that I put up and Mary Beth put up, and then Riley's Godzilla soil in a movie scene. Doesn't have to be that that detailed or specific, really. Just what can you notice about a depiction of soil? It could be a profile, could just be a pile somewhere. Mine's kind of more of a pile than a description at all. But what does it say about the movie, and does it make sense based on what we've learned in pedology? Does it fit the environment that the movie is trying to portray? Or since you know a little something about soil, does it make a little bit less sense to you? It's supposed to be a little fun activity, plus 5 or 10 extra credit points or so. I'll be watching for those to come in as we go. The last thing is that the final exam then is the only other thing coming up. The final exam scheduled time for finals week for us is Thursday morning. We are not going to do an in-person, a meeting required at all on Thursday morning. So if you're leaving before then, do not feel the need to stick around until Thursday of finals week. The final exam will be a Canvas test. I'll post it probably this weekend so you can get a start on it. I'm thinking I'll add a bunch of little survey questions to the end, probably for 0 points, maybe 1 or 2 bonus points. I used to have really good control over the course evaluation questions that you get asked, so I could get feedback like specific to my class of your thoughts and your opinions. But the whole course evaluation system changed, and now I only have specific questions to choose from that are similar for all the classes at the university. So I encourage you to please fill out the course evaluation. If you do it for one class, I ask that it's mine because I'm relatively early in my teaching career and I am actively trying to get better and incorporate feedback. I can't say the same for a lot of professors. So I will take your comments to heart and look forward to your input and your evaluations. Any questions on our way out of here? What's coming up? What's left to do this semester? Final exam. Nothing on Thursday of finals week. If you're still going to be around anyway and you want to, you go through all the effort of making these posters, but we don't really get to talk about them or share them at all. So I think I'll still be on campus. I can make a Zoom meeting for Thursday morning at 10:15, like our scheduled time. If you want to present or talk about your poster, that might be worth some extra credit points too. If you want to share what you found and all the effort you went through with your digging and your poster. So stay tuned for more info about that if that's something you're really interested in. Maybe send me a reminder too if I don't get that on the Canvas or the calendar at all. But we can discuss more on Thursday this week in lab. With that, we have more soil orders to get into our Ultisols and our Alfisols. The nice thing about these soil orders that we talk about, and especially our soil orders webpage, is that it's always going to be available. If you ever want to learn more about Ultisols or any one of the soil orders, all you have to do is Google Ultisols or the soil order, and the U of I website about it is one of the first results. So that's a great resource. I love having such a high profile, I guess. Our university, our soils program is a great resource to learn about all these soil orders and is a great resource for us to work through. I'm interested to see if the soil order, if the taxonomic system expands, figure out how we could update this with a potential 13th, maybe 14th soil order, and maybe be involved with that. I think that'd be really fun. But our topic for today, first of 2 topics, is our Ultisols. The last, kind of fitting where we are in the semester right now, from Latin ultimus. These are relatively old, perhaps not the oldest, but when the system, our taxonomic system, was first being made, focusing specifically on soils in the US, these are some of the oldest that we find in the lower 48. They're strongly leached, acidic, usually acidic forest soils, relatively low native fertility, humid, temperate, and tropical areas of the world. And this red color is really what stands out. They've got the highly weathered, oxidized iron oxide minerals in these soils have oxidized over time. And they also have, perhaps more important though, is they have the subsurface clay accumulation. Argillic, usually candic too, are 2 good options for these, and base saturation less than 35%. The only distinguishing characteristic between Alfisols and Ultisols, the reason I can group these 2 together into one lecture, is that they're practically the same. They have practically the same requirements except for this 35% base saturation. So base saturation means these base cations, calcium, magnesium, potassium, sodium, these positively charged cations that are also plant nutrients, micronutrients, potassium as well. Positively charged, you think about cation exchange capacity, they're exchanged on these negatively charged sites in the clay minerals because they're positively charged. These are the base cations as opposed to the more acidic cations like H+ or aluminum. A lot of aluminum on these clay minerals increases the acidity, which is why we see these acidic forest soils, and means there's less room for these calcium, magnesium, the traditional base cations. So it's measured by base saturation, how much of these available exchange sites, the cation exchange capacity, is made up of these more plant nutritious, perhaps base cations. When it's low, they've been highly weathered. These cations have been leached out of the soil. It's highly weathered. It's got a low cation exchange capacity. And when it's less than 35%, it qualifies as ultisol. 5 suborders, pretty common in the southeast US. But first, the global distribution. Pretty humid, kind of subtropical areas. You could say the really tropical areas like the rainforests, I'm thinking here in the Amazon, Central Africa, are more oxisols. They're the most highly weathered. They have those oxic horizons that have developed over even longer time. So everywhere else within these tropical, highly weathered regions would be the ultisols, very common in Southeast Asia as well. In the US, it's all about the Southeast, pretty much, Alabama, Georgia, South Carolina, North Carolina, Virginia, practically fully covered in ultisols, but we do have some California. California's got a little bit of everything. And on the Western Oregon, Western Washington, Cascades, where it's a lot of, they get a lot of rain, a lot of moisture there. You can have ultisols develop in these kind of old landscapes. Our concept diagram here, we've got the wet to dry, pretty typical with the aquolts, udolts, usolts, xerolts based on soil moisture regime, climate conditions. We also have humolts for well-drained ultisols that have a high organic matter content. They have high organic matter, but they're not particularly very wet. Really wet ones would be the aquolts, humolts, representing a lot of organic matter. So keep copping down suborders here on this one. We've got a lot of the green, the udolts, ultisols in the eudic moisture regime. In the southeast, generally east of the Mississippi, this kind of track along here along the river. It's probably newer soils, younger, more recent, deposited by river sediments. They're too young to be ultisols, but everywhere else in these kind of old, really humid landscapes, very likely to be ultisols. Aquolts, where there's a lot more groundwater availability, maybe closer to like the coast to lower lying areas, we'll see some good examples of these. Xerolts, ultisols with a xeric moisture regime, most common in California, it looks like. And then humolts, the ones with a lot of organic matter, are the one we find in the Cascades. Pacific Northwest ultisols. Okay. On to what some of these look like, some of these landscapes here. We got this really red soil there kind of in the background, but closer to the photo here, it's much more brown, not quite as highly oxidized, got that color. A coastal plain landscape, typical of broad, low relief coastal plain landscapes. Despite relatively low relief, considerable differences can be seen in the drainage. So in the foreground here are poorly drained aquolts, and the distance is redder, lighter color with udolts better drained. So could be from tile drainage. As water drains out, you get more oxygen available in the profile, maybe increased oxidation of these ultisol profiles, giving them this bright red color back there, but still kind of micro topography, topographic differences, causing big differences in the saturation and the morphology of them. So This is a poorly drained one, the Rains series. It's got the light gray colors that we come to expect with these G subordinate distinctions. Also within an E horizon leached out and also delayed out. That could be pretty hard to identify in the field, I think. Haley Aquold, it's very deep, poorly drained. Could be sandy clay loam or clay loam textures because it still has, it's got sandy textures because it's really well drained, and clay from some accumulation because it must have an argillic or a candic. Got this BT horizon here, subsurface horizon requirement to be the Ultisol in the first place. And we trust that it has the low base saturation. So where drained, can be used for agricultural production, water tables at or near the soil surface for much of the year in the kind of low-lying spots along the coastal plain. Maybe a better drained example, increasing in elevation here. A grossoranic candy udult. Grossoranic, this subgroup here means it's got a sandy or sandy loam texture. It's really coarse soil to a very deep depth. So it looks like a pretty normal soil profile from here, but when you look at the scale, it goes down to over 2.5 meters deep. This AP and this E horizon combined to be at least a meter thick. And it's got a really sandy texture here, which facilitates all the leaching out. Very high hydraulic conductivity, water can flow through this very fast and leach out all the nutrients, minerals, the coloring agents of the soil pretty much. And we got this E horizon formation to a very deep depth, over 1 meter. And then also we got plinthite showing up, kind of this reddish, white marbling in the bottom, but it's just too deep, it's too far down to show up in the taxonomic name here. Notable feature is the really deep E horizons to 1 meter. Plinthite is too deep to be recognized in the classification. It's got the argillic horizon closer to the surface in this example. However, plinthite can show up when plinthite occurs closer to the surface. This could be either a plinth udult or a plinthic candy udult here. Very deep, very well drained again. Dothan series. A candic diagnostic horizon differs from the argillic, and that's dominated by these low activity clays. So it's kaolinite clay specifically, it's that 1-to-1 low shrink swell, good for pottery. Yes, does not expand or shrink very much. Does not retain nutrients very well. It has a low cation exchange capacity to begin with, giving it a low base saturation. So very common to have kaolinite clays in the ultisols and these candic horizons. This is a candy udult. There's other options too, but the plinthite here is the special one here. As we mentioned before, it hardens irreversibly if exposed to wetting and drying cycles. So I think based on just the high humidity, they get rainfall pretty much all year. Why do we not see the wetting and drying and the permanent hardening into ironstone in the profile here? I think that as deep down as these are, usually a meter plus, it generally stays wet enough in the subsoil year round that it doesn't totally dry out. On the Palouse in the summer, the soil gets really dry. We would describe the dry color kind of by default in soils, and you only have to add water from the spray bottle in order to describe the wet color. But in a lot of other places, the Midwest, where I'm kind of most familiar, and the Southeast, the soil kind of generally keeps its moisture all year round. So you describe the moist color by default there. And I think down into the subsoil, even though it's a well-drained soil, there's no evidence of like prolonged saturation. There's just kind of a general field capacity or moisture retention that keeps the plinthite here from totally hardening out, turning into ironstone rock essentially. Can hapludults now are a little bit different than candy udults, but they still just have candic horizons. There's very slight differences in just how much of an increase in clay there is, just how much of a decrease in clay there is below the candic horizon. I'm not fully familiar with these because it's not really a system that I've had to work in. I don't expect you guys to learn that either, but there's a lot of options between hapludults, candy udults, these candic horizons. A little bit complicated. As long as you can match up candic horizons to kaolinite to ultisols, I endorse that. So This is now, yeah, this specifically the canned haploidults in the Piedmont region of North Carolina. We're increasing in elevation a little bit farther from the coast. It's bordered to the Appalachian Mountains on the west and the Atlantic Coastal Plain to the east, so it's kind of this in-between area. I think, as I understand, this is where Paul McDaniel did a lot of his PhD research, looking at the pedological changes on like this kind of gradient from the mountains to the Piedmont to the coastal plain in North Carolina, because he went to NC State. Ultisols are dominant, formed under metamorphic and igneous rocks, favorable climate, extensively long history in agricultural production. Some cases dates back to the time of early European settlement in the 1700s. So extremely long agricultural history here. In undisturbed areas, they probably have these E horizons with a thin A and these BT canned haploidults. I think about canned hap in here. A lot of rain, not really plowed, so we still have this E horizon, clay, silty clay textures in the BT horizons. So aside from just the fact that there's a BT here, this is even more the case for alfisols. There's really not a whole lot of other requirements or features to identify, horizons to identify in ultisols and alfisols. Cecil series, we've got a monolith of this one in the lab. It's one of the wide orange ones. North Carolina state soil. Could be a lot of clay, 35 to 60%. Again, kaolinites, hydroxy interlayered vermiculites. Interesting chemical properties of some of these old, highly weathered minerals. When they have a long history of cultivation, maybe over 200 years, they've got for sure an AP horizon. Maybe they used to have an E horizon, kind of like this one, except with enough erosion over decades, generations, centuries of agriculture, erosion has brought the surface level down, and then repeated tilling has kind of mixed up what used to be the E horizon into the AP. It's been incorporated with organics, fertilizer, and crop residues over time. So we don't see the E horizon anymore, even though they might have had one in the past. So this Piedmont region kind of here in the middle between the mountains and the coast, great place to find these canned haploidults. Generally better drained. We don't see the same kind of saturation groundwater influence like we do in the aquolts up here. And then the haploidults even higher up, maybe mountain ranges. This one is all the way in Arkansas, the Wichita Mountains. Could be sedimentary metamorphic rocks. Maybe less agriculture here, more just forestry land uses. We've got the E horizon. BTs, right? Not a whole lot else to look at. Must be a low base saturation clay, low cation exchange capacity in this argillic or candic horizon. A typical of many ultisols, A horizon, E horizon, BT sequence. Low calcium, magnesium, potassium. And then Blue Ridge landscape of North Carolina. Maybe more pasture and hay production than row crops, for example. BTs, maybe C horizon in more weathered bedrock. Micaceous is the mineralogy class here, and rather than mixed or siliceous is kind of the more common other one. So this is probably forming out of some kind of mica-rich bedrock here. I've been to Eastern Tennessee once, and that really stuck out to me was any kind of bedrock exposures. They're all really metamorphic rocks with the really parallel, like a thin parallel sheets, look like mica bedrock for sure, and that will show up in the mineralogy when it dominates. Argillic horizon has a clay loam texture, perhaps not as deep as other ultisols. It's only the argillic horizon itself is this 40, 50, 60 centimeter range here, and then the rest of it is C horizons. Less soil development going on there. Humults now closer to the home. This is Western Oregon, a humult landscape, typical of the Cascade and Coast Mountain Range. They get a lot more rain than we do in Moscow, right? Moscow is about 20 inches per year, so this is double. Perhaps relatively mild, wet winters, hot, dry summers. Same kind of xeric moisture regime. Used extensively for a variety of agricultural purposes, timber production. This example here looks like it could be in a winery area, vineyard. And this is the Jory Soil series, Oregon State soil. I was once visiting Western Oregon with my sister. We went to a winery, and I asked the person serving what they could, they can tell you so much about what goes into a wine and what makes it special and notable. I'm not too much of a wine snob, but I am a soil snob. So I asked, what can you tell me about the soil that these come from? My sister rolls her eyes, ha ha ha, what a silly question, right? But the person working there, I don't know what you call a server at a wine tasting, but she was very excited. Oh, of course. I took a soil science class, she could tell me all about the soil series names of each of the different fields or the different fields that these vines are growing in, and one of them was the Jory series. It's pretty important. The soil qualities affect the kind of grape production and the qualities of the wine. So if you have a chance, if you find yourself at a winery, I encourage you to ask. You can ask questions about the soil, what they can tell you. It's really important in the industry of winemaking, the whole environmental effect on grapes and the wine production. They call it terroir, the terroir of a region, and how it affects the grape growth and the resulting wine product. So not a whole lot of horizons, unfortunately. So as fun as it is to talk about the Jory series at a winery, maybe not that much fun to open up a soil pit there, because you really can't use much. I mean, the color won't help you, I guess, finding horizons. Maybe all structure differences, texture differences. I don't even know about structure differences either as well. Yeah. So maybe we're going on friable versus firm.
Yeah.
The moist consistency here, but what do we have? Is there a texture here? Silty clay or clay textures, variety of purposes, including orchards, vineyards, production of Christmas trees, crops, berries, grass seeds, timber, high organic matter contents, because it's formed in colluvium residuum from basalt, maybe. Could be nice and organic rich, thanks to the vegetation. This one looks a little bit different. A candy Ustalt. Do we have a humic one here? No exchangeable calcium below 10 centimeters. So it's really low native fertility. Apparently never cultivated. International example there. And those are the Ultisols. So the important thing there is the low native fertility. You have a lot of crop growth in these regions, though. They can be productive if you add a bunch of fertilizers to them. So agriculture is still a reasonable use. We've been using it a lot. They grow corn, they grow tobacco, Virginia, North Carolina, or have for a long time, probably with a lot of fertilizer added. So that's the good takeaway for Ultisols. Now, Alfisols, extremely very similar. They key out back to back in the taxonomic order. It's the exact same subsurface zone of clay accumulation. Argillic could be candic, could be natric, and base saturation of at least 35% or more in the subsoil. Second criteria distinguishes Alfisols and Ultisols together. So we had the nice and red Ultisol kind of as the cover photo for the Ultisol. That's not to say that all Ultisols need to look like that, but most of them do. The Alfisols is where that really varies. This is a white, slightly colored one for the Alfisol cover photo. Not all Alfisols are going to look like that. It gets broader and broader. The definition compared to some of the other ones we talked about first, Alfisol is much more broad. It's going to include much more soils that look quite a bit different. So mostly under forest and have subsurface horizon clay is accumulating. Temperate, humid, some humid regions, generally favorable climate and fertility for agricultural and forestry. 10% of the global ice-free land area in the US, almost 14% of the land area. So now we're getting much more broad, supporting 17% of the world's population, considering we've got all 12 soil orders. This is relatively overrepresented here. So Global distribution of alphasols, maybe a little bit latitude dominated, a little bit higher latitude than the mollisols. If you remember what that one kind of looked like, it was a kind of horizontal stripe across Central Europe and Asia here, just a little bit farther south than the alphasols are here, across the US and Canada, getting out of the oxasols in the middle of the Amazon here, ultisols closer. Now alphasols kind of right really in the middle, and then we picked up a lot more mollisols here in like the Pampas region of South America. And then same thing with Africa here. We have the oxasols in the really tropical regions, ultisols kind of in between, and then alphasols now bringing up the rear there. Percent of land area in alphasols is a really extensive coverage, maybe most in the Midwest, but we still have a lot of coverage elsewhere. Idaho's got them, Montana, California, even Texas. Even in some areas, they're less common in the Southeast because those are a lot more ultisols, but you can still have alphasols. Still have a little bit more of those exchangeable cations. Concept diagram here, very similar to the ultisols. However, we swap out the humults, the hum suborder for a cry suborder, a really cold one. Maybe it's a lot harder to find the highly weathered. Yeah, weathering process is a lot slower or less likely to fully develop in ultisols if they're really cold environments. But the rest of the ones we're pretty well used to now by the climate moisture regime gradient here. So really not that surprising. We see the cryic ones, the purple, showing up with elevation usually in the Rocky Mountains here, which we would have the coldest alphasols. Then the rest is all the moisture regime. So xeralfs could be what we have in Idaho. I see a little bit of yellow up there, cryalfs too in the higher elevations. But then the eudalfs and the aqualfs over here, east in the eastern half of the US. Starting off with the wet ones, the aqualfs, and this is another potential big revamp because we've got these saturated conditions. These glaying horizons could be really aquic if it's close enough to the surface. This is what a lot of pedologists out there right now are interested in reclassifying, taking aqualfs out of the alphasol suborder and putting it into the aquasol, special proposed soil order for specifically wet soils. So this could be reclassified, reorganized potentially in the future. But it's got these wetness features, right? The orange kind of rusting, the redox concentrations, glayed out matrix here with the G horizon dark gray color or pale gray color, I suppose. 3 parent materials, a little bit interesting here. What do we know about these? Maybe perched water table with some of the differences in texture. Fine texture sediments on terraces, upland benches, the head of drainages. So it could be different textures resulting from different deposits of sediments, maybe silty, maybe sandy throughout there. A haplocryalf, so a colder one in southeast Idaho, higher elevation, 6,000 to 8,000 feet maybe. Shrub mollisols are associated with shrub glassland communities, but the crag temperature regime, I suppose, limits our grassland and a horizon mollic epipedon development. Leaching facilitated by cool, moist climates, removing calcium carbonates, still accumulating the argillic BT horizons, silt loam, silty clay loam. Probably a pretty typical average kind of normal looking soil profile, getting more and more broad as we go. As long as it's got that this argillic horizon here at the increase in clay, and it's not already classified as another suborder. If we rule out the mollisols, we rule out andisols, spodosols, and all the other ones we've already discussed, then alphasol is kind of where we start to cross them off. So a little bit drier now. Paley style landscape in north central Texas. This Paley group here usually means it's relatively highly weathered. Maybe it's got a bright red color. Could be cultivated. This one it's got some very interesting structures here. Looks like blocky, maybe prismatic, kind of popping out at us, really strong structure. But this dark red weathered color. Udic Paley style. Loamy, very fine sand to fine sandy loam in the topsoil here, but then it increases a lot. 40 to 50% clay in the argillic BT horizon. Texas example, they can look like all kinds of things. Fragile landscape now, northern Idaho, eastern edge of the Palouse, so we're giving ourselves another shout out. This one's gonna have a potential fragipan at the bottom, dense and brittle layer, maybe or maybe not. Dense enough to restrict water flow here, create this leached out E horizon. This one's described as a Vitrandic Fragile. It's the same profile that we classified together for the first part of the soil taxonomy challenge, where we said it was an almost Vitrandic Fragile. But we keep the Vitrandic subgroup in here to demonstrate that we have volcanic ash mixed in with loess in the surface horizon. Multi-generational soil, 2 different age loess deposits here to give it a little difference in texture, mineralogy, maybe a little bit of volcanic ash too, mixed in with this BW rising. Santa series. Merry Early Christmas from the Santa series. Lastly, Dury Xeralf here for Central California. We can have Xeralfs in the xeric moisture regime, as well as maybe a Durapan at the bottom. So low precipitation, a lot of irrigation, could be used for vineyards, pasture, rice production. Probably low, I guess, interesting hydrology or water flow in these soil like this. Abruptic Dury Xeralf means it has an abrupt texture change. Old alluvium on low terraces, clayey subsoil, silica, cemented Durapan. So maybe this is a relatively coarse, or at least not a lot of clay up here. Extreme change with paramaterial changes, right? Into the 2 BT horizon, we got argillic, these clay films, BT1, BT2, they continue BT3, BT4. The change in paramaterial does not affect the numbering of the BT horizons. But a really extreme texture change here could affect water movement as well as the Durapan down here. So maybe just low carbonates, not carbonate cemented. If you put HCl on this one, it would not fizz because it's only silica cemented, giving it the BQM. So water flow is probably really restricted with the clay texture here, and definitely restricted, would not flow anymore if it reached the Durapan horizon there. Relatively shallow. UDALFs now to kind of bring up the rear. This is bringing it close to home for me. Iowa County of Wisconsin, a Moloch Hapludalf, well drained on the side slopes. Dark surface gives the soil an appearance of the mollusol, but lacks one or more of the mollusol characteristics. Maybe it's almost there on the depth, but just not enough carbon, not enough base saturation, over 50%, right, for the Moloch epipedon. Or the color maybe not quite dark enough. So it technically is a alfisol, but mollusol adjacent, mollusol subgroup. And then typic hapludalf of north central Minnesota, more glacial paramaterials, frigid temperature regime limits crop selection, mixed forest there. As long as it's got the BT horizon, could have an E horizon, a lot of them do, but they don't all have to. As long as alfisols or ultisols have this BT horizon, it's not one of the other soil orders. That gives it our classification. Fragile now, summit shoulder back slope of a loess mantled landscape. Post-glacial probably, with a more traditional fragipan, probably more prismatic structure. Could be a little bit of E horizon material leaching out here as water tries to get through anywhere it can. Pretty common in the more humid kind of eastern, midwestern, Indiana, Kentucky kind of region. Oxy Fragile, this oxy group, subgroup here means perched water table periodically forms. So part of the year it experiences some of these aqueous conditions, giving it oxyaqueous subgroup. Fragile BC horizons there. Pretty normal soils otherwise. I don't have a lot else to add there. Fragile prismatic structure probably. Molic means boron on mollisol. Then just to wrap it up in the last few minutes, some of the slides to talk about Ultisols webpage takeaways. Ultisols are highly weathered. They got the low base saturation, 5 suborders. Distribution on the map, I would look for the southeast. For sure, common horizons and processes, BT horizon, lessivage, accumulating clay. Could be a little bit of eluviation or glaying if they're poorly drained in the aquolts or aqualfs for now. Land uses could be forestry if they're undisturbed, pasture, or agriculture with added fertilizer because low fertility there. Ultisols are old. One extra comparison I like to make here is this is our map of ultisols, and this is for comparison a map of the maximum glacial extent. So the white kind of shaded glacial region is the most recent glacial advance. The dotted line here shows older ones, how far the maximum reach of the glaciers were, the actual advance of the ice sheet, and it lines up extremely, extremely well through Pennsylvania here. The farthest that the glaciers made it is the farthest south of the glacial soils is the farthest north of the Ultisol soils. So coming along through here, kind of the Ohio River Valley, right through the middle of Missouri and even out west here, the kind of notch right there lines up pretty well with our Ultisols. So maybe given thousands of more years, more time to weather, interact with the environment, all of the upper Midwest kind of glacial soils we know now will one day end up as ultisols because whatever soil was there in the past or in the southeast that did not get buried by or reworked by relatively younger glacial soils since the last ice age, those remain today as the ultisols. Any glacial soils, glacial till, parent materials, outwash, are just too young to be ultisols for now. Then for alphasols, similar kind of deal. Central concept for alphasols, non-cambic subsurface horizon, and not in any other order. It's got the BT horizons, pretty similar land uses for alphasols and ultisols. My favorite alphasol, this is an example from my career as a soil judger. This was in a Glossudalf profile in Kentucky when I got to judge there on the team. I really liked it because this kind of felt like the first time I was really grasping, okay, finding these horizons, interpreting the story of the profile. We got this fragipan down here. This is a good fragipan, extremely dense and brittle, very difficult to even sample with a soil knife of how just how tough, just how dense it was. But it's forming this glossic horizon here. We didn't really talk about glossic horizons in the diagnostic horizons, but it starts out, it's essentially a breaking down E horizon. So we had an E horizon that everything's leached out of, and then it's starting to turn back into a BT horizon. So we're starting to have mixed up these kind of BT/E characteristics going on, where you have stripes maybe of the E material mixed in with some kind of BT clay accumulations, got a BT horizon above it, and then a very abrupt kind of ruler drawn AP horizon right there, pretty deep from tillage effect. So this one, not enough carbon or base saturation or dark enough color to be a mollisol, so that makes it alphasol. Glossudalf from this classic horizon. I really liked it. I suppose, as with soil judging itself has a long history with alphasols, they're very hard to escape. We see a lot of alphasols pretty much everywhere we've been, between just since I've been the coach, Ohio, Colorado, Oklahoma, South Dakota, Iowa. We're going to Wisconsin in the spring. We have a lot of alphasols there. Really not until the national contest, not this spring, but next spring is going to be North Carolina. So that's when I'm already nervous now, I think, trying to figure out how to judge without alphasols, but exactly the difference between the the candic. How do you know it's a candic rhizome? How do you know it's a can-hap versus a candy udalt versus a regular udalt? That's coming up. Alfisols are pretty spatially sensitive, except for Nebraska. The very first soil judging competition I was judging at was in Nebraska. I remember a little controversial call. Some of the contest organizers wanted to say that I think it was a clay increase was just enough to make one of these profiles have an argillic horizon. And it didn't have a molic epipedon, so that would have made it an alfisol. That would have made it just about the only alfisol in the whole state of Nebraska, perhaps. My coach kind of disagreed on that. I hardly knew any of it meant, just as a rookie judger myself. But now I have much more of an appreciation for having almost seen an alfisol in Nebraska. But since then, alfisols are all we get. So good chance that a lot of the project pits that you guys went out and dug, if it's not a mollisol, if it's not an andesol, maybe a good chance it's a alfisol if you were digging around here. So with a couple minutes to spare, that's all I've got. I will see you guys on Thursday, and let me know if you got any questions in the meantime.
Thank you.